Our next speaker is Lauren. Lauren, are you around? Hey, how are you?
Good. How are you?
Good.
You're on to like hour 10 of this conference or hour 9?
Yeah, next year we're doing 24 hours. The sun is not going to set. And at the end, I'll just be doing IVs of coffee. It's going to be great. Uh, no, so Lauren is a very close friend. She has a PhD in psychology. Went on to do a postdoc with Gelman at Columbia, focused on multi-level regression with post-stratification. And the idea there is that you take a survey. It may be slightly biased. Let's just say that we accidentally survey too many males. We can take the estimates and we can apply that to a data set such as the census, which is less biased, and hopefully we get some more sensible outcomes based on that. Lauren now works at Monash in Australia, which is in Melbourne, actually, where my mum went to university. And the issue with MRP, multi-level regression with post-stratification, MRP, is that you have to do twice as much cleaning. And we've discussed the effect of cleaning decisions here a little bit throughout the talk. But this really means that we have double trouble, as Lauren's talk is titled. So Lauren, thank you very much for agreeing to give a talk. Over to you.
Oh, awesome. And thanks so much for having me and for inviting me to talk. It's a really nice conference and a really nice thing to talk about. And so I guess before I start my talk, I've been listening in. I did get up early so I could listen in to some of the talks before me. And I'm really impressed by how everyone is talking about the solutions they have for reproducibility or how they make it work in their own research fields. So my talk is going to be a little bit different because I'm going to talk about the problems and challenges I have. And I'm going to face a little bit about the fact that my work isn't super replicable, or the work that is replicable is kind of a little bit more boring than the stuff that isn't. And so I'm going to talk about why that is and some of the challenges that come up when you start talking about replication with survey data. So these are kind of my own opinions, but I couldn't have come to them without great discussions and collaborations with Dan Simpson, Kate Kana, Andrew Gelman, Yajun, Rowan, and Jonah and Nitsi, and a bunch of other collaborators as well. So these are sort of a whole bunch of ideas that have come out of different projects. So I hope it's sort of interesting. And if anyone has solutions or suggestions, I would be super interested, right? So there's this idea when we talk about replication. So I guess coming from a PhD in psychology, when I think about replication, there's certain things that come up, right? So there's things this idea of open data and open code, right, which we sort of advocate for quite strongly. There's this idea of pre-registration, which is quite popular in psychology and psychological fields, although a little contentious at times. There's this idea of code that if you gave to someone else on a different machine, they could be able to run it from end to end. And there's this idea where experiments where the effect is observed in a new population. So if you repeat the experiment but with new people using similar materials, you should see the same effect, or the same effect from the same sort of distribution of possible effects, right? And this is where the sort of replication crisis comes out, where we see that this doesn't happen as often as we would like. And so that's where I'm really coming with replication. And then I look at my survey data and bless it, it's so messy. And I don't see replication sort of coming out as cleanly as I'd like. And so what do I mean for this, right? Well, survey data is really messy. I think I've said that before. And I think anyone who's worked with survey data, especially sort of open text responses, kind of would agree with me, right? It's not always hand entered, but it's kind of even if you have a computer assisted entry system, people are still typing numbers into the keyboard. It's often, not always, but often quite sensitive. So it contains a lot of very, precious and private information about people. And so because of that, we don't often distribute raw data in its entirety. And And it's expensive. We're not going to do surveys over and over and over again. We're never going to see a replication crisis in the same way we see in psychology, because we're not seeing, you can't run surveys of 4,000, 5,000 people a whole bunch of times because they're very expensive things to do. So with that sort of in mind, what do I mean about this idea of dirty data, right? So let's just sort of take a step back and imagine our paper censuses, right? So you get your census, and I can remember doing this as like a little kid, and I was fascinated with it as a kid, and I'm still fascinated with it. It was kind of precursor to my research. You know, you get the paper and you fill out all the forms, and it's all very exciting to me. I don't know about anyone else. And so you're filling this all in by hand, right? And you know, someone somewhere is looking at your answers with your, you know, handwriting and trying to decipher them and enter them into some database, right? So of course, it's not everyone has perfect handwriting. And I think mine's been degrading as my education level goes up, which is an interesting effect. So this is me attempting to write my name, right? I didn't deliberately make it messy, but I didn't deliberately try and make it neat. And I was reading this and I think, well, I look at it and see Lauren Kennedy, and you might look at it and see Lauren Kennedy because it's a very common name. But, you know, if you just looked at this and you didn't exactly know that this was a common name, you might see, you know, Lauren Chemiclue, you might see Lauren Kennedy, you might see Lauren Kennedy, you might see Loin Chemiclue, right? So when you look at this and you're hand coding in the entries, you're bringing in your own and societally trained biases about what names are and what like the possible subset of names could be, right? And so you'll often see this or experience this when you look at names from sort of outside your culture, right? So you don't have the same common set of names as what other people would. And it's a lot more work for you to sort of decipher names and sort of sound them out and decipher handwriting, right? So that's kind of the first thing, right? So even just this step of hand entry, it's not really replicable. And more than that, it would differ based on who is doing the entry, right? Because we're all bringing in our biases. This is going to be one of the funniest examples that I've ever done in a talk. So, you know, now surveys, we conduct them online. So people enter in their own data, which is wonderful because they're typing it on a keyboard and you don't have these reading problems. So it should make it so much easier, right? Well, so say I asked you what your annual income is, and you know, there's different ways I could give you a text box to put in that number, right? I could say, I could put in the little commas and the decimal points for you. I could just give you a whole bunch of spaces. I could give you a whole bunch of spaces and then give you a spot for the decimal to kind of push you or indicate or nudge you to put like exact amounts and not just round. Or I could just sort of leave it open-ended and you could enter whatever you wanted, right? And these are all kind of viable reasons. There might be reasons why you want to push things, do it one way or another. And then let's say my answer is kind of, you know, roughly the median income for Melbourne, which is about 79,000 or 80,000. And so, you know, this is me trying to enter them in. And so, you know, there's lots of different errors you can do. You can start at the left and go along and then suddenly be like, oh crap, I've got to put a decimal and now there's more decimals. And, you know, that's an error. You can still start at the left. I start at the left when I fill out these forms where there's a box. So it's completely viable, like completely reasonable to do. In fact, you do that when you're entering your name and you have to like put in a letter for each box, right? So you would have to learn to do this for numbers differently from learning to do it for words. So you get to the end and there's a space. And so, you know, do you put a 0 in there? Does the computer put a 0 in? Does the computer register that as empty and then kind of push everything over? You know, you might do it accurately, which would be good. Or you might even go the sort of, I think this is European, where you use a comma instead of a decimal point. In which case, like, how is you know, if you don't think of this ahead of time, does this mean that you're going to have, you know, an income inflated by, you know, 2 decimal points? Now, I don't know if you picked this up because it took like 2 runs of my slide for me to notice this. I entered the number in wrong twice, just trying to make these slides. So it's there and there. I left this in for teaching purposes, but also to kind of emphasize this idea that, you're not going to be foolproof when you're entering in on a computer, even if it's information that you know, right? And you don't have that sort of data entry error of like someone trying to interpret your answers. Okay, so let's kind of push on this idea a little bit. So say you've got a survey and you're asking people how much they spend per week in rent in Melbourne, right? And you live in Melbourne, you have friends in Melbourne, you kind of know what you pay for rent. And so you get your distribution, it looks something like this, right? And that's tiny, I hope you all can see it. But like it's sort of centered around $400 or $500 a week. Melbourne is really expensive. But you've got this like one point out here that someone has reported paying $3,000 per week in rent, right? And you can kind of look at that and be like, well, did they mean 300 and they accidentally put an extra zero? Like, should I flag this as a potential error or something we should impute or something we want to remove and do sensitivity analyses for? Or is this like a legitimate thing that you can spend, right? Like, I don't know anyone who spends as much per week in rent, but maybe they exist. And so you start having to do really bizarre things like Googling or using real estate searches to see like how much $3,000 worth of a house you would get in Melbourne. Is it even possible, right? And it turns out there's actually a bunch of examples of apartments and various places in nice areas in Melbourne that are charged $3,000 per week in rent, and it's very nice to look at them. And so you go, well, okay, so this is a valid point. Someone could actually spend that much, even though I don't know anyone, they're not in my circle. But let's say now you have longitudinal data, right? And we're still talking about this one data point, but now you have longitudinal data. And when you look at longitudinal data for this participant, they sort of indicate that they haven't moved in the last like 6 years. And their income, the rent that they report every week is sort of 300, 300, 300, 3,300, 300. Now looking at this, you might start to say, well, it's probably likely that that was an error, right? If they say they haven't moved, I don't think their rent has sort of spiraled up to 3,000 and then dropped back to 300. And so that's kind of useful, and you start to sort of see that there's this like long set of decision-making processes. And there's a reason why I'm talking through all of this, because it gets even complicated, right? So now let's say the case reported that their household income was $1 million. So a lot of money, much, much, much more than the median income. And they say they live in a postcode that corresponds to an inner city, which is kind of an expensive location in Melbourne, like very expensive. So there isn't really many places for rent that are $300 per week in this area, right? And they're earning enough that they could like viably spend $3,000 a week in rent. So now what do, right? You're making this long sequence of tiny decisions and research and discovery to try and decide whether this point should be flagged, whether it should not be flagged, whether it should be imputed, whether it should be used in a sensitivity analysis, right? And I actually don't know the answer because I made this case up, but you can imagine that these things actually do happen. And how does this relate to reproducibility, right? Well, firstly, these things are really hard to talk about because you can't share cases, not like this. You can't share this sort of individual level data because you can't really talk about them without talking about all the special features about them when we don't normally talk about cases like that in a survey because then it's identifiable. And then secondly, you have to sort of realize that this is a long sequence in microdecisions, right? It's a decision to say like, hey, this is bigger than the rest, than the rest of our distribution. And then to say like, hey, but this is a possible value. And then to say, well, it's not consistent with the other values that they've reported over the last 6 years. And then to say, but, well, they could earn enough to pay this amount in rent. And then to say like, well, it would be hard for them to find a place to rent in the area that they've reported for, 300. So maybe all of those other cases were a data entry issue, right? And this is really kind of a long sequence of micro decisions, and it's one data point for one case, right? So when you think about a survey more generally, there's thousands and thousands of these decisions going through, hundreds of thousands, which I don't know if you have in Toronto, but they're like little tiny candies that you put on top of cupcakes. So many of them, and they get everywhere, right? You open the jar and the jar just like, they roll. They're like round, they're like sprinkles that are round, and they just roll throughout your kitchen and you keep finding them. Despite your best efforts to clean them up and sort of put them in nice, in bin, hopefully, it's like glitter. You'll find them for months and months later. So each one is kind of justifiable, right? It's a good thing to have in there. And it's kind of codable, right? Like if you code in all your decisions into this, you can code it up and say, well, this case we're removing or we're recoding or we're leaving them in, right? But is it genuinely possible? And this is kind of an open question. Is it genuinely possible to code in every single micro decision that you make in the process of looking at your very messy survey data? And even if it is, would it be possible to pre-register all of these micro decisions? And I'm not saying that they're all impossible to imagine, like these ones are pretty common, but I can guarantee that even if you imagine as many as you can, when you get your actual data, there will be something surprising that you'll have to ask these questions for. And I don't know whether it's just me, but I think they're almost an unimaginable set of possible things that you might end up asking these questions for. So why am I bringing this up? Well, in a sense, it's because like I want to talk about this idea of reproducible decisions, right? So if you assume, and you're kind of going to have to stay with me and say like, well, these decisions, they are important to make, right? This can have huge issues for your data fidelity and for noise, and for like, you can get some really crazy conclusions if you leave in the really bizarre survey responses that are clearly errors in. What do you do, right? Well, you can code in every single micro decision ahead of time. We've sort of talked about that. It's not quite feasible, right? You could relate and post-clean data for comparative studies. So this is an option, right? And then you could think about, well, maybe we'll code every single decision and we'll release our code open, right? So I think these are kind of the two options we have to start talking about reproducibility. And to talk about the first, we have to kind of take a moment to say, well, this data is really sensitive, right? And survey data, like, it's not always really sensitive. Like there's some things we would consider to be not super sensitive, like, for example, like cognitive experiments, where people are trying to learn a fake language. Well, that's not super sensitive because it's not identifiable in any real way. And also like, what does it matter how fast you can learn a fake language? But in other senses, when we're asking about income and about geolocations and about contact details and various types of minority status, immigration status, these issues are very sensitive, right? And so that's kind of what I mean when I talk about survey data. It's so precious because there's a lot of trust involved in it. And so when I talk about this, and I think it's kind of important, although not super common in science, to talk about, to be a little reflective of our values. And so my values 100% are like protection of participants and respect for them. So like particularly their anonymity and also like their respect for their data. And reproducibility comes second. Sorry, Rowan, I should have warned you about this before you invited me to talk. And so that's kind of the lens that I'm taking this, right? So like my first priority is to keep people safe, and my second one is to make science reproducible. So when we look at that lens and we talk about releasing pre and post clean data, you suddenly start to see a little bit of an issue, because what you would like to do is do this, right? And then you can do basically sensitivity analyses, run your analyses on both of them. Super nice. But survey data, at least the stuff I work with, is rarely released raw. We take all the interesting stuff out. We do top-bottom coding. We might do data swapping. We might actually completely simulate the data set and do differential privacy. And the difficult part of this is the data inconsistencies, which is often what we're talking about when we're doing cleaning. They're likely to have been removed anyway, right? Because we would top code them or bottom code them. Now, that doesn't mean that we would, they wouldn't be important still, right? Because whether you're top coded at $1,500 a week or whether you're stuck at 300, that's a big difference. But they're likely to have been removed, and so you won't see the full implications for it. So the other option, and I think this maybe is intuitively what we normally do, is record all of our microdecisions in code. So this is kind of, we release our cleaning code, right? And it's every single decision laid out in code, and it's completely reproducible. I give you the unclean data set, you clean it, and you just run the code, right? And you can see everything that's happened. Now, the thing you have to notice for this is that you can actually accidentally release data that you would have never released publicly in the first place. So what do I mean by this? This is readable, right, Ron? Hopefully. I hope you can read this code. So
yeah,
this code sort of says, for those who are not like super familiar with R, this code sort of says like, hey, if your subject ID is 2303 and your rent is 3,000, recode it to 300, right? And so this basically says like, hey, subject to 303 reported rent of 3,000 and where it's been replaced with 300. So you can completely go backwards with this. So maybe you would say like, oh, well, we'll flag it for imputation instead, right? And so that's the same thing, right? You would say like, oh, well, where there's a flag for imputation and your subject ID is 2303, then their rent was really reported as 3,000, right? Identifiable again. You can go backwards. And so maybe you'll do something a little bit neater. So you'll say like where the max rent for this participant is located in your rent column, replace it with 300, right? And this is better, but then now you're kind of starting to lose the reproducibility of your actual decision, right? Because it's becoming less clear why not you did that in the first place. Hopefully that makes sense. So we have this like balance. It's a balancing act between protection and reproducibility. And we see this balancing act come out when we start to talk about public data and private data. And I am really over time, so I will talk quickly. So I guess many surveys release public data which has sort of identifying information removed. And so you can do analyses that reproducible. If you can sort of get the public data, you release your code, everything's really reproducible, right? This data, if you're a methodologist like me, will often lack the interesting statistical features of real-world data. Outliers, particular variables, especially geocoded ones, the weirdness of income distribution is often removed so that it looks a little bit nicer, which is great if that's what income actually looked like, but it doesn't. And so methodologically, I either publish with private data, which can never be released with the paper, and so it's only replicable for people who meet the right criteria to access, which is not everyone, or I simulate data and then it's sort of not, it's removed from the particular example we're interested in. Okay, so what does that all have to do with MRP, right? So Rowan, how much time do I have? Do I have like 2 minutes?
Yeah, that's fine. You can go a bit long. It's fine.
Okay, cool. Sorry. So what does this all have to do with the MRP? Well, like Rowan said, we sort of talked about how MLP is kind of this two-step procedure. You have a model, you fit it to your survey data, and then you predict it in the population. So there's the same challenges that you run into with MRP with the survey, but then you also have a population to deal with, right? In terms of reproducibility and data cleaning and all of these things. And then you have to deal with the relationship between the survey and the population. And again, there's all of these micro decisions that are going on. And in fact, Amber sort of mentioned some of these before when she was talking about the things that are coded into your health data, right? These are the sorts of undocumented or rarely documented decisions that are going in that can reflect huge biases of society or personal biases. And like, this is kind of the things that we want to be reproducible. So I've talked a little bit about this already. So I will mention just quickly, MRP does tend to require like actual survey design information that we tend to remove from public data sets. So for example, we've got a cluster sample of schools and you want to run an MRP, school should be a predictor. But if you have a public data set, you almost always remove like the cluster ID like school, because generally it's identifiable, it's quite sensitive, lots of reasons. So this is normally accounted for in survey weightings using replicate weights, but there's not really a good solution for this for MRP. So the other challenge that I wanted to talk about is sort of like this idea of the population information. So this is sort of this idea that you have a population and it's the census, but it's not always the census. And where it's not the census, it's not always publicly available. For example, the analysis in Gitzer and Gelman, not publicly available post-stratification data. In this case, because the information is proprietary. For other cases, it can be for normal sort of survey data protection reasons. And lastly, and this is kind of what I wanted to spend a little bit more time on, but I will just mention really quickly, we have a paper on this sort of idea of the micro decisions that go into mapping your survey to a population. And so when we do this, what we end up doing is kind of finding a measurement in the survey that matches a measurement at the population level, and then smushing the labels until they're kind of analogous, and then using that as our sort of adjustment variables. And it turns out when you do this, they rarely match exactly. And so when you do this, you end up making a whole sequence of tiny micro decisions about what's analogous and what's not. And so this comes up when you talk about race ethnicity in surveys, because you're binning your data down, which means you're aggregating different groups of people together. It also comes up when you talk about sex and gender and the sort of relationship between the two, and that's what that archive paper is about. I'm horribly over time, so I'll skip my slides on that and I'll just jump to my conclusion. And that's that I was problem focused. None of these things are solutions, right? But they're problems that are hard to publish on because you don't, by nature, they relate to the privacy of the data, and so you can't talk about the actual data examples. And so you have this balance between data protection and reproducibility. And so like just a few things, like, you know, maybe there are levels of reproducibility, like in-house, you have code that runs end to end, but out of house, kind of people just have to trust you. But also there's this idea that reproducible decisions should go beyond code. So more than just like coding your decisions into your code, but also the underlying values that you've taken into making them, and sort of the reasoning behind it as well. So that's it for me. I'm sorry for going over time, but thank you so much, everyone, for having me.
No, not a problem at all. Thanks so much, Lauren. That was just wonderful. Yambo's got a question. Do you think that you could provide some type of probabilistic guarantee by fitting a non-parametric or parametric model to the distribution of the data? Like if you flag the 3,000 per week rent event, then you consider the probability 1 minus probability of that rent is over this, and take the product of those probabilities over all the micro decisions as a proxy measure for the impact of your decision.
Yeah, maybe. I feel like when this has actually come up, it's just been it's like been a discussion between the team members, sort of talking about various features of the data and trying to make a decision about how to use it in the next stage, which is often like an imputation stage. So sort of deciding what to do with it, and they can only, and it only really happens as one decision, but I guess you could see it as like a whole bunch of decisions. But it takes into account a lot of the case-wise information. So I think that would be hard to quantify the probability that, rent is over 3,000, because rent is over 3,000 given your income is $1 million is a different like probability, like different decision than rent is over 1,000 given your income is 10,000.
Yeah.
Does that answer the question?
Yeah. So in the context of, self-promotion alert. In the context of language models, so I have this preprint from, and it's like, what proportion can you forecast of next words? And how does this change during the cleaning process? And so Paul and I are working on an equivalent for quantitative, for like numbers, sort of like your idea. And so it's a different way of getting at it, Yambo, in terms of like trying to, like, what proportion can you forecast? How does this change over time, given the other factors, exactly like you're saying. But I like Yambo's idea of sort of like looking at it in this other way. But yeah. Does anyone else have any other questions that they wanted to ask?
I did see there's one in the chat about data sets used by multiple researchers often cleaned up separately by each user, and whether there are examples of crowdsourcing data cleanup.
Yeah.
So just to answer that really quickly, sorry, Ron, I want to answer it, so I'll jump in real quick. The surveys I've worked on, data cleaning has often been like a discussion. Okay, so data cleaning will happen by like the main data cleaning when it's simple, but where it's complicated, it will be like a meeting about this one case, and normally quite a substantially long meeting, where we discuss all of these factors. So I guess that's an example of crowdsourcing. I do think it's important to note that like each survey is doing this individually, so the decisions that I would make on the surveys I work with are probably not the decisions that someone else's would make with another survey. And again, it's reflecting the values of the survey and also the aims of the survey. And I think like one thing we don't do with quantitative research very much is be very reflective of why we're doing things. But I think that's important to realize, like there's reasons why we make these decisions, and they, to do with our values and research aims.
Thanks for picking that one up. I also coined a law named after you. It's Kennedy's law. The data are always weird and ways you can't anticipate. So I'm going to try and make that a thing.
Genuinely, the best part about doing research with people is like they will do crazy stuff, and it's just like miraculous. It's wonderful.
Sylvia, did you want to ask any questions? Or?
I guess not as question per se, but you've just really got me thinking about a lot of different things. And like on one hand, a lot of the issues that you brought up with happen with EHR data all the time. Like patient addresses are spelled all sorts of ways, which then affects the geocoding that you can do later. And that's just one example. Or even how staff enter prescriptions and how they spell medications, all these sort of things start to come up. But on on another very tangentially related point, so I had written in the chat box that I really like this idea of reproducible decision making, because when just in the idea of sharing code with other people and having people be able to understand even what you're doing, I think has a lot of accessibility implications as well, to even just know why somebody made the decision that they made, why they use certain functions to create certain plots, you know, why are these things important? And I don't think we really spend enough time documenting these things or know how to. Yeah, so thank you.
I think it's very like they're really excellent points. I think it's really time consuming. So that's one of the funny things, like that paper we wrote on sex and gender was literally because it came up on our project. And so we have to make a decision about this. What are the sort of options? How can we make a decision? How can we communicate this decision? And then sort of realizing that no one had communicated how they were making this decision. And so like just that one little decision, and we make thousands of these in a survey, right? Or with any data set, turned into like a 15-page paper, right? But I think it's good that it's there because there's so many biases that could have gone into that decision. And by talking them out really clearly, we can sort of say how we're preventing against them. We can recognize that they exist. And yeah, it just really makes me think about like just representation in data more generally.
Yeah, well, I'll just say thank you once again for your presentation. And yeah, I hope you're able to join some of the talks tomorrow as well. Thanks, Lauren.